The moment I found this great resource for GRE practice questions, I knew I needed to do several videos on it. I'm not sponsored by them, but the link is in the description. They're made by Manhattan Review and the quality looks good. I'm going to do 10 quantitative comparison questions, which comes up exclusively in the GRE, but all the concepts that I'm going to discuss are relevant also for the GMAT and other exams. Let's start with this question. I haven't seen the questions before, and we're going to check the answers at the end if I get any wrong. It says here that xy is greater than 0. Thinking about that, that means they both must be positive or both negative. Now, by the way, feel free to pause the video, come up with your own answer before I give away what I feel. But I feel that if they're both positive, then quantity A would be bigger, because when we have even powers, it stays positive, or it has to be positive, whereas quantity B, if x and y were both negative, quantity B would be a negative, because x cubed, it's an odd power, it would stay negative, and a negative times a positive would be a negative. So quantity A would be bigger, because if both x and y are negative, then quantity A would be positive, and quantity B would stay being negative, because again, it would have a negative times a positive. But now you're thinking, what happens if they're both positive? And many of you would say that if they're both positive, quantity B would be bigger. And that's true in some circumstances. For example, if x and y are integers like 2 and 3, then because the powers in quantity B are bigger than the powers in quantity A, then in that scenario, quantity B would be bigger. So when they're both positive, integers that is, quantity B is bigger, but if they were both negative, quantity A would be bigger. So I would say the answer is D here, depends on the situation. Let's move on to the next question. It says this one is challenging. In the figure shown above, line segment BC has a length of 16, okay? Rectangle FABE is a square, so all equal sides. And the area of rectangular region FACD, the whole thing, equals 612. Interesting, they don't tell us anything else. So because we don't know the length of this square, the side length, I'm going to make up a letter. It's a perfect opportunity to use some algebra, is when there's a specific length or amount that we don't know. So I'm going to call it x. And I know the top and the left is both x because it's a square. This would give us an equation. We'd have the height of the rectangle being x times the length of the rectangle, which is x plus 16. And that gives us the area of 612. Okay? And we could expand this and say x squared plus 16x, and then bring the 612 to the other side, take away 612. This is going to be challenging to factorize this. Is there an easier way? Do I need to work that out? Area of FABE or the area of the other one? Basically, I just need to check. You know what? I'm not even going to solve that. It looks too hard. I'm just going to check if x is 16, do we get a bigger area than 612? So I'm just going to compare it. If x was 16, we would have 16 times 32. And I could whip out my calculator at this point to answer that. I get, obviously you could try that in my head, but 512. So I know that x is going to have to be bigger than 16. So notice I avoided solving that equation. That's initially how I was going to solve it, but then I changed my mind. It looked too hard, so I changed my methodology into picking numbers. And I realized x has to be bigger than 16 because if I make x 16, then 16 times 32 is not going to get us a 612. So x would have to be bigger, making FABE bigger than EBCD because x is bigger than 16. So quantity A is bigger here. Okay, that was quite challenging. Next one. Working independently, machine A can complete a job in 3.5 hours, while machine B can complete the same work in X hours. Working simultaneously, they can together complete the same work in 1.5 hours. I've done a video on this, work rates, But essentially we convert the time for machine A into a rate by doing the reciprocal, 1 over 3.5. We convert the time for machine B into a rate by doing reciprocal. And that adds up to the combined rate. And how do we find the combined rate? Well, it tells us the combined time is 1.5 hours. So the combined rate must be 1 over 1.5. Now, yes, I would immediately try and get rid of the decimals here because the decimals are horrible. So times top and bottom by 2, so that's 2/7 plus 1 over x stays the same, equals 2 over 3. Now, this is a technique I was doing with a student the other day, but what can we multiply this entire equation by to get rid of all of the fractions in one go? We could multiply by 21x. We want to multiply by something that's a multiple of all the numbers, the 7 and the 3, and the letters, in this case x. If we multiply everything by 21x, 21x cancels with a 7 to get 3x, giving us 6x left over for this first fraction. 21x cancels with the x in the second fraction to give us 21 times 1 for this fraction. 21x cancels with the 3 to give us 7x, which times by 2 gives us 14x. And look how much easier that is compared to the previous step. All we'd have to do now is take away 6x from both sides, and we get x as being 21 over 8. And 21 over 8, well, 24 divided by 8 is 3, so 21 over 8 is slightly less than 3. So quantity A is bigger. This is a great one to re-watch if you didn't understand every single step, because it's the perfect demonstration of both how to solve work rate questions and how to simplify fractions in equations. That was a great one. I'm loving these Manhattan Review questions. A driver completed, this also says challenging, scary. A driver completed the first 20 miles of a 40-mile trip at an average speed of 50 miles an hour. Stop there, let's immediately work something out. 20 miles, that's a distance. Let's use a triangle, DST. Don't stop trying, distance, speed, time. And we know the distance is 20 and the speed is 50. So we do 20 divided by 50. That's 20 over 50, 2 over 5, 0.4. So that takes 0.4 hours or 24 minutes if you times it by 60. So that's 24 minutes so far. And the second 20 miles, an average speed of x. Okay, so that's 20 over x would be the time taken for that thing. The average speed for the entire 40-mile trip was 60 miles an hour. Interesting. Okay, so the entire 40 miles, they did at 60 miles an hour. So using the triangle, we've got a distance of 40 here. I'm just using the triangle again and again and again. The distance for the entire trip was 40. The speed was 60. So if we do 40 over 60, that's 2/3. 2/3 of an hour is how long it took in total. And we know in the first leg that it took 0.4 or 2/5 of an hour, 24 minutes. Let's keep it in hours though. So first 20 miles took 2/5 of an hour. Second 20 miles took 20 over x. Distance was 20 and the speed was x. Again and again using this triangle, d over s. And the total time was 2/3. Again, I got that by doing distance divided by speed. Now, you guys can tell me, what can I multiply everything by to get rid of all the fractions? 15x. I'm going to go a bit faster now to show you how it's done when you've got some practice. There'd be a 3 left over giving us 6x. There would be just 15 left over giving us 300. And there would be just 5x left over giving us 10x. So that's 300 equals 4x. And of course, we could probably do that in our heads. 75 equals x. And if 75 equals x minus 60 is still bigger than 10. So quantity A is bigger. These are definitely challenging questions, but they're testing really core concepts, so I really love it. Next one, it's going to be 10 today. A positive integer x is a perfect number if the sum of all the factors of x, including 1 and x, is equal to 2x. Never knew that. Okay. Oh my god. The sum of the reciprocals of all the factors of the perfect number 28. The sum of the reciprocals of all the factors of the perfect number 28. I could work that out manually, obviously by adding up all the reciprocals of all the factors. So 1's a factor, so the reciprocal of that is 1 over 1. 2's a factor, 4's a factor, 7's a factor. I'm sure they asked this for a reason, like there was a shortcut involved. That's the sum of all the factors, or sorry, the sum of all the reciprocals of the factors. But why did they tell me all this stuff though? The sum of all the factors is equal to 2x. I think they're baiting me into thinking that this is all going to add up to 2. But this isn't the sum of all the factors. This is different. What they're asking us for in the actual quantity A is the sum of the reciprocals. Like, there's no quick way of adding those fractions. Maybe if we make it 1 over 28, make them all over 28. So we'd have 28 over 28, because 28 is going to be a multiple of all of them. Plus, I can see what's going to happen. Plus 14 over 28, plus 7 over 28. Yeah, the top line, so it was relevant. The top line is going to be the thing that adds up to 2x. And how do I know that? Because the top line, when I try and add all these fractions together, adding all of these reciprocals together, the top line is just all the factors. And so it told me in the question that the sum of all those factors is equal to 2x. So that's going to be 56. 56 over 28 is 2, so the two quantities are equal. Really interesting question. These are fun, wow. I need to do more of these Manhattan questions, they're great. Okay. They're quite hard level though, I'll be honest. So if you're getting intimidated, don't worry, I can do an easier section next time. This is difficulty level challenging. The sequence of this is such that the first one is -2, the second one is -5, third one is 4, the fourth one is 3. And then it says the current term, to translate it, the current term AN is equal to the term 4 terms ago. AN minus 4. In other words, the fifth term, the next term, is going to be the same as the term 4 terms ago, which was minus 2. So basically, this is a long way of saying the pattern is going to repeat every 4 numbers. So it's going to be -2, -5, 4, 3. -2, -5, 4, 3. Again, you might want to rewatch that if that's not clear, but that's what they're saying here. The current term is equal to the term 4 terms ago. So it repeats every 4 terms. Anyway, the sum of the first 64 terms. Well, I know every 4 terms adds up to what? That's -7. Adds up to 0 actually, doesn't it? -7 plus 4 plus 3 is 0. So every 4 terms adds up to 0. So because 64 terms is a multiple of 4, there's going to be exactly 16 lots of 4. And each of those 4 adds up to 0. So this 64 terms adds up to 0. And I believe 98 is also a multiple of 4. What is it? It's like 7. Wait, is that multiple of 4? Times 20. No, it's not. It's not, is it? Because you get 20, which is 80. 16. It's like 24 times 4 is 96. So then the 97th term and the 98th term will be -2 and -5. Because every multiple of 4, don't forget, adds up to 0. So the first 4 terms adds up to 0. First 8 terms adds up to 0. First 12 terms. But 98 is not a multiple of 4. 96 is, so we know that all the terms up to 96 add up to 0. But then the 97th will be -2. And then the 98th will be -5. So all the other terms before that add up to 0. But then we've got these -2 and -5 left over. So it's going to add up to -7, meaning quantity A is bigger. All of these feel kind of like 160 to 170 level questions. But you guys were asking for harder level questions, so that's what you've got in this video. Okay, the arithmetic mean of the list of numbers above is 4, and A and B are integers. You guys love this, and you know what I'm going to say. When you tell me a mean, what am I going to do? I multiply to find the total. If there are 6 terms, and I know the mean is 4, I know the total is going to be 6 times 4, which is 24. So this adds up to 24. Adding up the numbers, we have 10 plus 3 plus 3, that's 16, plus A plus B equals 24. In other words, take away 16 from both sides, A plus B equals 8. Now, how does that help us? A and B add up to 8. Well, we know quantity B already, the mean is 4. So the median of the list. Well, let's try out some numbers. We know A and B are integers. If A and B are like the numbers 4 and 4, for example. At this point, I'm not sure what to do, so I'm just going to try out some numbers. Then the list would be putting it in order 1, 3, 3, 4, 4, and then a 9. And then the median there would be 3.5. So I know the median might be 3.5. However, if A and B are not 4 and 4, and instead they're like 0 and 8, what would happen then? If there were 0 and 8, the list would be 0, 1, 3, 3, 8, and 9. In which case the median would be 3. So is it always the case that the median is going to be smaller than the mean? Let's try one last example. Let's do 6 and 2. If it's 6 and 2, the list would be 1, 2, 3, 3, 6, and 9. And again, the median is 3. So I'm very suspicious that the median always seems to be smaller. Yeah, the median is always smaller, so I think quantity B is bigger. In the real test, I might try out one last set of numbers, like 7 and 1 or something, or negatives, but to be honest, I'm pretty confident it's B based on these examples. But yeah, for now, I'm just going to move on to the next one. Okay, X is chosen at random from the set 1, 2, 3, 4, and Y is chosen at random from the set that. The probability that X, Y will be even. Okay, to find out the probability that a product will be even, it's much easier to find out if the product will be odd, because that can only happen in one way, with an odd times an odd. An odd from this list is a 2 out of 4 chance. An odd from this list is a 3 out of 3 chance. So the chances of an odd times an odd is a half times 1, because 3 out of 3 is 1, which is a half chance. So if there's a half chance of it being odd, there's a half chance that the product will be even. Again, much easier to find it out that way around. Okay, the probability that X plus Y will be even. For a sum to be even, it has to be an even plus an even or an odd plus an odd. An even plus an even is impossible because there's no evens in the second list. An odd plus an odd is 1/2 chance of an odd here in the first list and a guaranteed chance. So that's 3 out of 3. So again, we've got a half chance that the sum will be even. Again, to remind you, for the sum to be even, it had to be an even plus an even, which is not possible, or an odd plus an odd, which is a half chance. So the total is a half, again, for the sum to be even, meaning both quantities are equal. These are exceptional questions. Definitely check out the link in the description. 2 more to go. We've got this inequality, and they want us to find some stuff. I would immediately multiply both sides by 3 to get 12 is less than 7 minus x. I would add x to both sides. So x plus 12 is less than 7. Take away 12 from both sides. X is less than minus 5, or negative 5. Okay, x is less than negative 5. What's the maximum value of this? The maximum value. Well, if x were a negative times a negative would cancel, but then we'd have a negative on the outside of the bracket here. Meaning that the deeper down we go in terms of negatives, the more negative quantity A becomes. For example, if I make x minus 100 or negative 100, we'd have 5 take away negative 100, which becomes 5 plus 100, which is 105. But then with the negative on the outside of the brackets makes it negative 105, which is a really low value, but we're trying to maximize the value. In other words, to maximize the value, you want x to be as big as possible, which in this case is practically exactly minus 5. I know you're not allowed specifically negative 5 because it says less than, but close enough, for example, negative 5.1 or something, and that would give us 5 take away negative 5 is 10, negative 10. So that's essentially the maximum value of this, but it can't quite be that. And the maximum value of 2x is the same thing, right? Because 2 times negative 5 is negative 10. And if we make x any smaller, like negative 6, then 2 times negative 6 is just getting further down. So both of them have the same maximum value, I believe. Very fun question. Next one. This one. Okay, could just pick numbers, couldn't we? P over Q, Q over R. Could pick numbers, and that would prove the point. However, we know no relationship between those, so I can kind of tell already it's going to be D. But, okay, let's pick some numbers to demonstrate. First of all, we must remember the principle, which is you want your examples to be as different as possible. So in my first set of numbers, I'm going to have them all very close together, like 1, 2, and 3. In which case the first fraction is a half, and the second fraction is 2/3, making the second fraction bigger, quantity B bigger. However, in my next set of numbers, I'm not just going to do 2, 3, 4. I'm going to make my example as different as possible. For example, I might throw in a half in there, because it didn't say they had to be integers, and I might throw in a really big number for R, just to freak them out, like 100. Okay, that's a very different example from the first one, so it will help elucidate the challenge. P over Q here is a half over 1, which is a half again, and Q over R is 1 over 100. So this time, do you notice, quantity A is much bigger. So when you're picking numbers, it's a great method to do. This gives us the answer D because we can't tell. Sometimes it's quantity A, sometimes it's quantity B. But remember to pick examples that are as diverse as possible to really hammer home the point. That was a great set of 10. I'm going to quickly check if I got them all right and report back to you. So here is the interesting news. I got them all right, aside from this one. And this one, it says that quantity A is bigger. Now that's interesting. Where did I go wrong here? I did 12, take away 7 from both sides. That's 5. Actually, let's just show explanation. That'll be quicker. Open explanation. Okay, so I was right about the inequality. I factorized it correctly and solved it. And I was right about that. And this one, oh wait, did I just forget that it was 2x? Oh, that's silly. Otherwise, all the others were correct, and that was a really fun set to do, actually. That was really exciting. I'm definitely going to do more of these in the future. Do let me know if it was helpful. Definitely a challenging set of 10 questions.